Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Space Telescope has made a groundbreaking discovery that hints at the possible existence of another universe beyond our own. Its latest observations of the early cosmos provide evidence suggesting our universe may have collided with another during its earliest moments. Scientists have found strange, ancient galaxies in this distant past that defy current scientific understanding. These findings indicate that the early universe may have been drastically different from what we observe today. By peering farther back in time than ever before, Webb has revealed unexpected cosmic structures and phenomena that challenge existing theories. Alongside these discoveries, the telescope has detected bizarre events that have astonished astronomers worldwide, reshaping our view of the universe. The vastness of the cosmos has always intrigued humanity, sparking enduring questions about whether it has an edge or stretches on forever. According to current observations, scientists estimate that the universe began around 13.8 billion years ago. Building on this foundation, scientists developed a standard model to explain how the universe has evolved over time. However, recent data from the James Webb Space Telescope is challenging some of these long-held theories. With its unmatched ability to peer deeper into the early universe, Webb is prompting a re-evaluation of our current understanding. While the traditional view holds that the universe had a clear beginning and has been expanding ever since, new findings suggest it might not have started in the way we thought, or that its initial state was radically different. During the 2024 International Space Science Institute Breakthrough Workshop in Bern, Switzerland, researchers presented a new study titled The First Billion Years According to the James Webb Telescope, focusing on this critical early period of cosmic history. They examined the first billion years after the Big Bang, a time when galaxies took shape, stars ignited, and black holes rapidly gained mass. Studying this era requires extremely powerful telescopes. While Hubble could observe galaxies at redshifts up to 11, Webb has pushed that limit to an impressive 14.32. These deep space observations reveal that the earliest galaxies were much brighter and larger than scientists had previously expected. The galaxy known as JWST 14 is estimated to contain several hundred million times the mass of our Sun. This remarkable discovery raises a compelling question: how could such a luminous, massive, and expansive galaxy have formed just 300 million years after the Big Bang? Adding to the mystery, astronomers have detected carbon in a galaxy that existed only 350 million years after the Big Bang, suggesting that the ingredients necessary for life may have been present much earlier than previously believed. Even more surprising is the presence of oxygen, which indicates that multiple generations of massive stars had already formed and died by the time this galaxy came into view. Altogether, these findings show that JWST 14 challenges current theoretical models and simulations about galaxy formation in the early universe. Based on existing observations, scientists expect the James Webb Telescope to soon detect galaxies at redshifts up to 20, peering back to when the universe was just a few hundred million years old. However, this potential has sparked concern in the scientific community. If Webb were to observe galaxies even older than that, it could fundamentally reshape our understanding of how galaxies form. According to the standard cosmological model, there's a point in time known as the Dark Age, a period right after the Big Bang when the universe was filled with neutral hydrogen, making it opaque and devoid of stars and galaxies. Everything we currently understand about the universe beyond the Dark Ages is purely theoretical. What exists beyond that remains an enigma. Unexpectedly, new images from the James Webb Telescope have uncovered galaxies that appear to have formed before the Dark Ages. This finding has left scientists puzzled, as it challenges traditional ideas about how galaxies formed in the early universe. Even more perplexing is that these ancient galaxies seem vastly different from those typically seen from earlier periods in the universe's history. These discoveries raise deep questions. Are we possibly witnessing a completely different universe? Why do we continually find massive, mature galaxies the further we look into the cosmos? If the current laws of physics are correct, observations of the early universe should reveal smaller, younger galaxies with a clear point where galaxies and stars were non-existent. Yet, as Webb's observations push back in time, revealing increasingly large galaxies at earlier stages, it suggests we may be seeing a universe where different physical laws may apply. Beyond these massive, bright galaxies from pre-Dark Age times, other phenomena are emerging that challenge existing theories. Recent research suggests a surprising new twist in our understanding of the universe's origins. It's possible that the fundamental laws of physics, which we rely on to describe the universe today, may have functioned differently in the early cosmos. A study published in the Journal of Cosmology and Astroparticle Physics suggests that gravity may have been approximately 1% weaker on large scales during the early universe. This conclusion came after analyzing data from the cosmic microwave background, the faint radiation left over from the Big Bang. The CMB is crucial for studying the universe's early stages, including the formation of the first galaxies and events right after the Big Bang. However, researchers found discrepancies between their existing models and the observed data. By adjusting Einstein's theory to incorporate a 1% decrease in gravity, the models better aligned with the observations. This slight modification implies that Einstein's theory may need to be revised when applied to the early universe. Another major issue in cosmology is the conflicting measurements of the universe's expansion rate, as highlighted by recent observations from the James Webb Telescope. These findings suggest that the universe is expanding unevenly. Several different methods of measurement have been confirmed to be accurate, eliminating the possibility of error. This inconsistency points to the possibility that the cosmological constant or dark energy, which is thought to drive the universe's expansion, might not actually be constant. Instead, its value could vary across different regions of the universe. These discoveries are making it increasingly clear that as we explore deeper into the early universe, our current theories are struggling to keep up. One possible explanation for this asymmetry is the theory that our universe may have collided with another during its rapid inflationary phase. The multiverse hypothesis suggests that our universe could have formed near another one, and as it expanded rapidly, it may have interacted with its neighboring universe. This collision could help explain why the laws of physics seem inconsistent in different regions of the cosmos. For example, the southern part of the universe might follow a different set of physical laws than the northern part. This theory could also shed light on the existence of massive, ancient galaxies only a few million years after the Big Bang, as well as the directional variations in the universe's structure. These inconsistencies between theoretical models and observations are revealing deep mysteries about the universe. Ongoing data from the James Webb Telescope continues to offer new insights and suggest alternative explanations for the origins of the cosmos. Ultimately, this could mean there is a significant gap in our understanding of the universe, or that the early universe functioned in ways beyond our current comprehension. And that's it for now on Spaceverse. From Webb's discoveries to new cosmic theories, there's so much to explore. Drop your thoughts below and see you in the next one.